first thing we're going to bring, actually, the only thing I'm going to bring in is just the wall locations. Cool. And because I said this is already the correct aspect ratio, if I just bring it down to composition, it makes that composition for me. And this is the right aspect ratio to start off with. Okay. And we can, copy this over, or we can just hide and unhide the PNG, and we're working in the right composition settings. These things are, it's nice and long. So you have to kind of think about how you want to subdivide out all the information. A lot of times when I'm working with this, selecting the layer and holding down T gives you opacity. It's kind of good just to keep it visible and just kind of give you an idea of this kind of stuff, like where everything is. I also just kind of, this is something I just threw out that I've made before, is little masks so I know where the corners are. Because sometimes I just don't need to know where, sometimes I make them for the columns. Just give yourself little tick marks where certain things are. I don't want to do it where the door is. I don't want to do it where columns are. I want to target the doorway and that kind of stuff. It's important to kind of make your own content, make your own templates to give you the kind of flexibility that you want and need. Great. I don't have any content, I think, here, so I'll just make like a really large noise gradient, unless somebody else has generally large content. I'm sure some people do. Let's do a fractal noise. No, let's not do it on there. Let's do it. Let's do a new layer just to not mess with that one. New, solid, sure, great, fractal noise. Cool. So isn't this gorgeous? Let's make it evolve a little bit. Make it have a little bit of evolution. Keyframe. That's our... Alright. So zooming in. It's evolving. There, I just did everyone's wall for them. And this is not going to play back in real time. Remember that you can actually preview in different kind of resolutions, and I can go to like a quarter speed if I want to see if I can get a little bit more faster scrubbing through this. Now, this is a bunch of like kind of indescript patterns. So for me to take, this is like my final product, right? I've made my beautiful wall, but I know that I have these wall locations. I'm going to put it on top, and therefore I can see where they need to go. And I want the center of my project, which is going to be right here where this anchor point is. I want the center to actually be in the center of that north wall, so that it's right across from the plasmas and it's right in the center of where the event will be. So let's just bring like another shape on here, like a rectangle tool, and just actually let's bring a new layer. You're dying. Yeah. We got to pre-compose. And then if I go in here, I can put, that's the wrong one. Yeah, what's up?
What does the black shape on the location mean?
That, if I come back into doing this right, okay, so the black shapes are where there actually is a mask inside of the watchout, and it won't render any content whatsoever. So this is where the stairs are on the next to the screening room door, and this is where the ductwork was on the south side and next to the bathrooms. So if you have really important content, you need to know not to put it there to design around that, because it won't show. Because they don't want to project on the, they don't want to have what looks like a spill onto those ductwork, because it looks a little sloppy. So these are where no content will show whatsoever, and it's important for you to know that you don't have anything like words that go across there and stuff. Cool, so let's pre-compose this green solid is what I meant to do. And in the center of this one, let us put a little square, just so that we know where the center is of our project. New layer. Sure, and it's going to be just, something like this. And that mask, let's do this again, do it from a different color. No, there. Anyway, this is super simple stuff. I'm just being really specific. All right, let's make it red. Cool. And we'll do a little mask. All right, and this is just so we know where the center is and we can align it. And it should all be in the center. Now if we go back up, let's turn it off. Let's turn it off. We can move our composition accordingly. You can do it with the arrow keys, or I could just select it again, and if I bring these wall locations on top, I could see that my content can come over, holding down Shift so it doesn't go out of alignment horizontally, and there I can line up the center of my content with the north wall. And that's just what I want to do for this one, but this is good for knowing, in general, how to change the content center for any kind of site-specific location. So there we go. And I don't need this imagery, but if I just take off the, put the fractal noise back on, it covers it back up. Cool. And then the only other kind of plugin I need to do is, let's say, okay, so I don't need those. I don't need my locations anymore. And I just have my content. But my content I want to stretch and I want it to repeat. This will be a little hard to see with me using a nondescript pattern, but let's go ahead and go for it. There's a thing called reptile. I guess it's called reptile, like a reptile, right? Reptile. I don't know. You guys tell me. I don't know. And we just want to expand it out to the left side. Oh, expand it out to the left side. And it's a lot of pixels, so don't be shy. Just keep on going. It's a lot of pixels. And what this is doing is it's kind of wrapping it around and showing the side that's being cropped off back on the other side. Cool. And then it gets to the edge, and there we go. Voila. Now, the one thing that's going to be kind of hard to see, and I just kind of painted myself into a corner, I realized that, oh no, we can see it. There's a seam. All right, can you guys see that? So that's just going to happen because that's where the image meets itself back around, if you're thinking about it around a tube, right? And this actually brings in, this tool actually has something for that. It's just a blend layer, and you can kind of do this little thing, and it kind of finds the pixels from either side and kind of blends them together. There's a couple of different modes. You can say just to your own degree of how much you want to do it. I just try to barely hide the edge just a little bit so that it doesn't introduce content I didn't try to create, and it's crossfading with each other spatially. Cool. And that's could be designed around as well if you want to make something that's more infinitely tileable. This is more geared towards maybe something that you've already created, like doing something with the IAC building. This is you don't want to re-render the entire thing, for that kind of stuff. So you don't. I'm telling you, you don't. Right? And so even though again I didn't make the greatest art in the world, we do have a functional piece of content that we could put on that wall. Let's bounce it over to the media server, or sorry, to media encoder. And what I'll do is I'll save this and put it on the drop on the Slack so you guys can have it for yourself. So we'll just do this. I'll do that after class though. Cool. And again, because After Effects no longer supports H.264, and that's that watch out version's built for, we have to balance this over to Adobe Media Encoder. Okay, great. File, export, send to Adobe Media Encoder. Watch it load up. And this is where we're going to do the slicing. And I could probably just do the one wall, and you guys would get the plasma wall, but we can go as far as you guys need for this. I don't want to bore you with repetitive croppings. But it definitely, I thought it was a little bit counterintuitive, so it's worth showing. All right. So hopefully Adobe Media Encoder hasn't changed in a year and everything's the way I did it last year. So we'll take a spin. Let's turn off flux because I can't see. That's a little brighter. Okay, so give it a second. It's going to probably just show up. All right, let's force it. Let's go back. There it goes. Showed up. Great. So let's take a look at the settings first of all. So it was a H.264 at 15 megabit constant bit rate. Just to confirm, we have the document that I handed out. That's a different building. There. That's a different building. Let's open it up again. Again, our watch-out system has H.264 by constant bit rate of 50 megabytes per second. Let's do that. So here's where your presets are. We can create a preset if we're going to do this a bunch of times. Otherwise, I can just make one and copy it over a bunch of times. Yeah, hear those fans spinning. All right, so here we are. And we don't need to worry about audio because we're going to do audio as a waveform. And then we're going to make it a H.264 matching the source. Let's go to the audio again. And then the bit rate is down here at the bottom. It defaults to VBR, variable bit rate. We want to make sure it's constant. We want to make sure it always looks nice. And we're going to increase the bit rate to try to make sure that it has as much information as possible for our media server. And that is pretty much all we need to do. Simple enough. And now we have a preset which we can actually save if we're going to do this like another time. I can, if I go back in there, I can say save as. Can I do that here? No, that's fine. Preset. Anyway, so we have this, and this will be going off to a folder. I'll do this in my downloads. I don't want to sync it to my Dropbox. So I'm just do it in my downloads right now, and I'll create a new one for IFP. Cool, and it's going to be called whatever the name of your project is, IFP role. And I can make this first one 01. And then I can copy and paste it or duplicate it a few times. Duplicate. This one can be number 2. Save. Right click, duplicate. Because remember we're going to make 5 total. And then we'll go back and make, once they're all the identical preset, then we'll go back and do the cropping. Oh, I should duplicate it first. And one last time. Cool, so there they are. Let's go ahead and now we need to edit their source. And I might have to remember where to do this. Let's see. 64. All right, source. So here we have the source, and we need to crop that source. I made it each one the full one, and then we're going to crop each one in order of how they should come out to Tom over at IFP. By selecting this crop button, it opens up where we want to crop information from. And we want to make sure that our numbers 1 through 5 are left to right. That's just how their system is, and that makes sense to most people here. And then we just go through this document and do it as it says, as really straightforward, but again, it is a kind of unique workflow that my assumption is that it's somewhat antiquated, but maybe if anyone's seen this other ways, it's fine. So H.264 is both limited by its amount of information that it can carry, and also the computer has its own limitations for why these things have to be a certain size. Let us go ahead and get the list. We have the list. Now we'll just do it one by the pictures. So the first crop is, that's the second one. The first crop is we crop off all the way from the right 724 pixels, meaning that our first image is going to be 1,000 pixels long. Okay, so on the right side, it's 724, and that is our first image. That's the first video. Easy enough, right? So we say okay. Oh, sorry, no, that's sorry. It's 2,000 pixels wide because it's 924. So we cropped off 724. Each one of these slices is going to be 2,000 wide and 800 tall until we get the last one, which will just be the remainder of what we have left over. So let me do that real quick. Cool. So one's there. Select being able to crop it, and then we start from where we finish, right? So this one was on the right, 724, and this one's now going to go to 2,000 to 523, and the rest of them are going to be to 23. Okay. So 2,000 on the left, and then 523 on the right. 5,023 on the right. There we go. Makes sense. Looks like it fits. Next one. That is 4,000 to 323. 3023. 4,000. Try that again. 4,000. Let's try that one more time. 4,000 to 3023. There we go. Looks right to me. And then the last one. Or not the last one. Almost the last one. 4,000 to 323. 6,000 to 1023. 6,000 to 1023. 6,000 to 1023, and then the last slice. So, you know, once you make your content, this part isn't that hard. It just can be done, you know, pretty quickly, depending. It might be better for you, instead of just sending out an After Effects comp, to like maybe pre-render it at a high resolution codec, so that you're not actually trying to process effects at the same time as trying to crop it. Just bring in the final video. And the last one is 8,000 to 0. So just left side 8,000 to 0. There we go. And now we just hit play, and those will all come out, and then they're all labeled correctly, and that's it. The same thing happens with the other one, but that aspect ratio is 3 HDs wide, and we would want to crop that to the 3 HD slices. No matter how you want to subdivide it in for content based off of rows and columns of the screens, it's still going to be 3 HDs wide. Cool? So I'll let you guys figure that out. If you have any questions about it, we could definitely go over it another time, but I feel like that gets the watch-out system covered, straightforward, standard playback, right? And if you want to learn about a very old version of watch-out, which, you know, there it is for you. Great. So we're going to pivot real quick, and I want to talk a little bit about to the folks looking at doing interactive installation, and we did After Effects before, and we did our mesh warping for content using After Effects when we did pre-rendered content, but now a few of you guys actually did it in more interactive real-time content for that work session, but we really wanted to address that now. So I'm going to do a little bit of max patching and talk about how to share frames over the GPU, which is super swift, and it's a thing called Siphon. So, does anyone know the significance of Siphon and this building? Siphon. Yes, Siphon. It's a beast with 5 eyes, and he comes out every Tuesday. No, Siphon was a thesis at IDM. It was made by a guy named Anton Marini in like 2010. Yeah, and so he's otherwise known as Vade, which is a lot more dynamic of a name. So if you were to look up Vade, yeah, he's apparently it's also a whey protein scoop. I hope he knows that. Maybe it's him. He just like was hit the student list, was hiring kids for his new startup in Dumbo. Vade.info. So you can kind of see his progress from being a student here at IDM learning Max, learning VDMX, moving into, he actually worked for the Foundry and did After Effects plugin writing for a few years, then did a startup doing kind of like a more interesting and glitch-filled version of Instagram, which got bought out, which was good, and then doing a bunch of great shows. So he's a real deal. He's like a real coder and stuff. And he and another gentleman who was actually the gentleman Tom who converted Touch Designer to Mac were the two people on Siphon. So if we look up Siphon, you can see that it is a tool for all creative coding platforms, even for After Effects and Cinema 4D and other things like that, that shares video frames across the graphics card. And this is all touches on stuff, like I'm taking the torch back from Oren, where he introduced all these concepts to you guys, where he was talking about CPU versus GPU, CPU being a single processing unit, and a graphics card being a parallel processing unit that lets you do more rendering at a quicker speed without bottlenecking your performance, right? And so this was started off as a way of knowing that the image lives on the graphics card and any application can steal it, and it costs nothing for the computer to continue to steal it. I've had installations, or I've had live projection shows that have gone from Unity, had sent two different scenes out of Unity that could crossfade inside of VDMX. They went to Open Frameworks to do a pixel mapping that then came back to VDMX to be on top, running from this laptop, for a 4,000 person rave. It's super powerful stuff, and we're going to dive into that today, right? For those of you on PC, PC's version is called Spout, and Spout is by a father-son VJ team, and it was first called Wyfin, but now it's called Spout. I mean, and again, it's all the things. It's all the things, right? It does all the software you can possibly imagine. Most of it's free, but sometimes, like what we see in the world of After Effects, things do cost money. But I think it was a nominal fee. Like to be able to do like this kind of stuff is pretty cool for like $2.99 or something ridiculous. And then, so what's cool about these also is that if you want to send them to each other, this is the first way we could talk PCs to Macs on graphics cards. So there's a thing called TCP Spout and TCP Siphon that are also free to download, and you can do it over like a router, and you can send graphics between Spout and Siphon. So that's super exciting. So your Mac can go to a PC. You can imagine doing a little bit of rendering here and then distributing that across other computers that might want to add more effects and send things to, like there's some like for instance when Touch Designer was only on PC, this was a thing. Yeah.
I think as I was looking into this a couple months ago, I think now actually instead of using leaves which have been deprecated, you're better off using NDI. And VidVox has released some NDI safe and NDI spout tools.
So the next thing that I was going to talk about was NDI. And so there's a company called NewTek that's been around since forever, and they made the first like video toasters. These are giant rack-mounted media servers for real-time computing, and it's how they did the teleport on and off stuff in like Star Trek and stuff like that. And they do broadcast solutions, and they made a thing called NDI. Which is kind of like the video parallel to OSC, where the whole future of broadcast is all over Ethernet. And NewTek NDI is supported by it's actually supported by Unreal for doing like real-time graphics stuff like that for broadcast. And it has a huge suite of tools, Mac and Windows. Again, it's over network. It's super fast. It does up to 4K. I think it's limited to 4K, whereas I think we've pushed Siphon to more than that before. But this is like more of a standardized thing that's dealing more with like broadcast standards versus like some crazy artist hack, right? That's kind of fun. So this is now big. This is big. This means like the broadcast world is like, oh shit, yeah, you guys are right. This is good, but it's free. They're not charging for this, and they've accelerated it. And they also have audio support as well, I do believe. And again, there's a custom plugin for Unreal that we use, which only receives textures. It doesn't send textures, so we still have to use Spout to send textures or just send out video signal over cards. So anyway, this is the historical component of this. Let's take a quick little look at this. I'm just going to make a quick little patch and then show how we can send that out to something else, okay? So minimize all that junk. And we're just going to do, I don't think I've actually shown the webcam, so we'll just do a new object called jit.grab. And we're going to do the object that Orange showed us called new jit.pwindow, so we can see what we're grabbing. And we need to open and close our webcam. So we're going to send some messages called open and close.
These days you can actually just use a toggle.
Cool. Ooh, yeah. And that's what I saw when I was looking at the Visi2 objects. That's what they were doing. And then we need to, let's make a render context. So we saw that we could do a jit.world, and we'll start simple and build up from there. So jit.world is sending out a frame, our window, and then we need to toggle it off and on to turn it on to the rendering. With this on, it's sending out renders. It's sending out a bang, right? So it's pulsing at a certain rate, and that's actually what's updating all the video content, right? So I want to go ahead and get these bangs and be able to send it to my my video grabber. So I could do a send and receive. So send the bangs, and then I want to go over here and receive the bangs, just for organization's sake. New receive the bangs. And if I click open now, or as when I said toggle, I can be able to see what's going on, and there I am. Cool. So I was messing around, I came up with a quick way of doing one of those video synthesizer looks that we looked at, the RUT, and I just want to kind of show that, and then we'll move into how to send that over to other content. Although when I'm in After Effects, I'm just doing fractal noise, but when I'm in Max, I want to do a RUT. So what I'm going to do is I'm going to kind of go in two parallel ways of thinking. If we remember the RUT, it was kind of a way of giving depth to video image and then applying maybe the color back to that. So I'm going to go in two parallel ways. I'm going to send my color out, and then I also want to send out some sort of depth information. So let's first send out the color and store it to kind of a texture name. So this right here is on my GPU, but I'm just going to, by sending it to a texture, I'm going to name the texture just for organization's sake so that we can stay in that texture domain or rendering context. I'm going to say, let's call it RUT. And then I want to send it to a named space. So we're going to say at text. Why am I not getting any?
I think you misspelled.
I said geo texture. So we're done. This is a haunted object. I'll just delete it and start from scratch. Texture called RUT at and we can see all the different wonderful messages and attributes, and I want to send it out to draw to at name. I'm going to send it to a certain name, and that name could be Etra for us. Alright, so this is an OpenGL texture that whenever I make another OpenGL object, I can grab that texture anywhere and pull it on. Now that covers my color information, my RGB, into my graphics processing unit so that I'm rendering as quick as possible. But now let's deal with how we're going to offset that. And the way we're doing that is we're going to use a luminance channel. We're going to use a grayscale information. By converting our RGB to grayscale, we're going to use that to push this image out in depth in Z. Cool. So that was the jit.grab object that I hit open.
Oh.
So I can close it and open it, and there I am. Cool. So let's do a new object called new jit.rgb to Luma. It's already built in for us. If you guys can see something, let me know. I didn't realize how small it was. So now we automatically have a grayscale thing. These image planes are, in general, like we're dealing with matrix data. There are 4 planes, right? You guys know RGBA, right, or ARGB. I don't want that information. I want to deal now with X, Y, and Z, and I want to have X, Y coordinates for my texture. I want to set up a matrix so that I can convert it to a GL object and put this thing on there. So the jitter matrix is a vast, interesting thing, and I wanted to get into slit scanning too, but it's its own kind of real-time thing that we could definitely do in office hours another day. But for right now, we just want to take this plane and convert it to a 5-plane matrix that's in GL units, so a float 32 data. So if I say new jit.matrix, and I make it a, let's see, a 5-plane matrix, and it's at a data type of float 32, I'm now ready to go into OpenGL land with X, Y, and Z, and X, Y, and texture. So in OpenGL world, everything is kind of, the unit is an OpenGL unit. Okay, all the way left is a -1, and all the way right is a +1. And same thing with up and down, right? The center is 0. But if you think about textures, textures are kind of like your canvas in JavaScript, where 0, 0 starts off at like the top, and 1, 1 is all the way at the bottom right, right? So these 2 units are kind of going to be referencing different 0 to 1s or -1 to 1s to show the full image. And that's called the difference between those data is like a normalized data between 0, 1, and that's how we'll do that texture. And then there's a, what does S norm mean again?
Sine norm?
Sine norm. So a sine norm goes -1 to 1, kind of like a sine wave, right? So let's create a new object called jit.gen. And this is a way for us to do a little bit of shader math really quickly, and for us to do basically the entire Rhodetra in one object. Or two, a few objects. So this opens up a whole world of hurt, and basically it's a way of saying plus, minus, divide. Like all we did with that JIT operator that we did on the first day, and I gave you guys the patch. You can take 2 feeds and kind of cross-fade them different ways, and think about like you're just taking pixels. Like if this is, this our information is 122, and this one's another 20, then it's 144. Just think about like stacking these matrices of different math, like they're columns in space. But we just want to make sure that we have the 5 bits of information that we had before from our matrix. We want to talk about X, Y, and Z and texture X, Y. We talked about S norm, which is -1 to 1. That's our OpenGL information. And when you're in this, when we talk about the shader math, the way you unpack and pack things together is actually called swizzing and vecking. So we're going to say swizz my X. I know that sounds really funny, right? I'm like rapping up here. Swizz my Z. Swizz my whatever. A little free flow poetry. Anyone read?
This isn't a new patcher?
This is a subpatcher. This is this jit.gen object. You double click on this, and it opens up a new little way of doing shader code, but by doing it with a patching way. What's interesting about this, I mean, this is beyond the scope of this lesson or this class, is this could be exported and used in other software. This becomes, I don't know about gen, but definitely jit.pix.
You can even export WebGL.
Yeah, so you go to WebGL and all that kind of stuff. So this is really cool in that you can export. And the audio version of this, which is gen with a little tilde, can also be used for doing, I don't know, is it music shaders? I don't know if that's
Yeah,
what
you can make it like make BSVs and stuff.
Yeah, so you can make your own plugins, your own codes. These have really great functionality for doing quick math and exporting it and actually creating, again, more value, just like when we create executable out of Max. So I really like how dynamic this is. And then we need to get our Z, which is our depth. So we're going to swizz Z. And then just as you guys would guess, we need to get that texture X, Y, and Z as well, and that's coming from a norm. And then we're going to swizz X and Y for that one. So new swizz X, new swizz Y, and there we go. So this is basically saying we're going to take data from a 5-plane matrix, and we're going to also make sure we're working with data with a 5-plane matrix. I want to have a parameter that I can use to move my z in and out. I want to multiply by a parameter so I can make it make it audio reactive and bounce, right? Have depth. So there's no variables here unless I say there's a variable. So that would be a new parameter. I want the parameter to be depth, right? I want it to multiply my video signal by depth, this grayscale information. If I try to say new times depth, it says, it's already there. Maybe it already has my other object open. It should say no. To declare variables, you have to call it a param first. Param depth. And you can give it a default value, like 0.5 or whatever. We'll start off with just giving the variable. And then our input, new in1, and this is what comes from the top, the inlet, is right here, will be multiplied by depth. New star dot depth. And we're just using the grayscale image to be back and forth. And now. Cool? So we need to now pack this back into one vec, which we're going to claim it as a bunch of floats values. So it's going to be vec new vec 0 space 0 0 0 0. These are the 5 ones that we want to deal with. From previous experience in looking at the help files, I've realized switching things from basically regular rendering to OpenGL rendering flips my stuff upside down. So I want to accommodate for that here, since I've already kind of made the pie and seen that it came up upside down. So I just want to think about first again, if we're dealing with upside down for y, we won't remember that we're going from -1 to 1. So just by multiplying by -1, we'll switch it. Okay? So new times -1. And let's bring in x and y and z. And then this one, x will be fine, but y will be inverted. But remember, it's inverted from the corner, right? To draw from the opposite corner, that's using like the exclamation point negative by 1. Let's see. X, is it? I did a 1, negative. The opposite. Do the opposite of this. There we go. And then make it all come down to out. Cool? So we just made a little math shader code for doing, bringing through just standard values for x and y to make sure that our OpenGL texture that's called rut will match onto this. And then we're going to have just a variable for pushing z in and out. Yes, yeah.
So if we're doing, so we have a 5-plane matrix coming in. We're getting the depth is the z of that matrix.
Mm-hmm.
So that's the third plane.
Mm-hmm.
So okay, I'm a little
why we didn't jump around and do? You can do a jip unpack and jump 3 or whatever if you want to deal with it by itself. This is just the way that it kind of worked for me. Is that I'm getting the 5-plane matrix and I'm not doing anything with the other data. It's just the data that comes through as is. Yeah. I don't need to turn it to a variable. If I want to put a variable on it, then I can expose those different routes. I'm just render as is.
Yeah.
Good day, sir. Z, you come here, boy. I want to do stuff with you. Cool.
What is? I can't see what that one is on the right hand side. Swizz y.
Swizz x, y, and z.
And then it's not. It's saying not -1. What is that?
So the y is going to be upside down, and so
on the inside.
on the right side, this is the opposite of do the opposite of what you're doing. So instead of just flipping it based off of being like this, we need to take it from the corner and do it like that.
That bang minus means like 1 minus whatever comes in.
Okay.
Instead of
The exact opposite of what you do. If you're doing this, give me this.
Okay.
Where the other one, we could just flip you around because you're based off of a -1 to 1. That's that signed normalized data versus normalized where it's taking the canvas and doing the exact opposite of what it should be doing. Cool.
Is
So,
there a space between the?
yeah, there's a space after the minus here for the 1, and over here there's a space after the asterisk before the -1. Bang minus is the object, is the operator.
Oh.
Yeah. Do the opposite of 1. Cool. And so Oren told us about video plane. I think he spun it around once to show us it's actually a three-dimensional object that's just like a two-dimensional object in the 3D world, which sounds like its own little song about just being a two-dimensional object in the 3D world, making it through the day. But there's many types of planes and stuff like that, but we're going to deal straight with a mesh. We know that we want to put it on a mesh. So
What happened to the plan depth object that was at the top of the submesh?
I just zoomed in so you could see everything else.
What's that for?
This is declare a variable.
Oh,
Yeah, we've said that we're going to make a variable or a parameter called depth that we can utilize for processing. We're going to use it in a second. In fact, to address it, we have to then prepend or send in a variable of depth with a $1 so we can send in a value. So here's our float, and we can send in values to depth, and that $1 carries in this number, and it addresses this parameter right here. So as I move this up and down, it's moving that multiplier of depth. Cool? The one thing I did forget, though, is I have to create like dimensions for this matrix, and it's actually we're going to deal with just doing a 640 by 480 at first. This is the dimensions of the mesh. We actually don't need that many dimensions. In fact, I'll make some other dimensions in a second because it might be too comprehensively, computationally expensive. Because again, this is just going to be geometry pushing and pulling. Our texture information is up here at this geotexture. So let's make this a 640 by 480 thing. There we go. And I'm going to save real quick so that I can hand this guys off to you if we want to. So this is rut Petra. Cool. So we're going to move on to the jit.gl.mesh. Right, this is another GL object, and we're going to give it the same name as our texture called rut, same rendering text context, and we actually need to give this main render a rendering context. This is just good form. It's not always necessary on very simple patches. You see that I have a gray image here. I want to go ahead and add an erase color of black 0001, and we'll stop with that for right now. But we can add things as we see fit. Let's go into this mesh, and let's give it a texture. So we're going to say at text. Where is that? At texture, Petra. So we just reconnected this OpenGL objects back to each other. Turn it on. Open. Where'd you? Is it name? I said I didn't put anything here. Look at that. At name. There we go. And there I am. Cool? But what am I also? I'm depth. So let's finesse this a little bit and get to where we want to be. All right. One of the first few things that's fun to do is we saw Oren did a handle, so let's do jit.gl.handle. This is a way of adding a little like thing to rotate around with our mouse, right? Called rut, and it has a couple of attributes we can give it to it. So we can say that I don't want to look at it. I don't want to see those ugly crosshairs in there. I just want to be able to move it around. So at visible. Did y'all? I did that again. I've been sloppy. Yeah, I don't want that. I was doing that by mistake. I've been fighting that for years. You know. So I don't want to look at it, but I want it to auto rotate because I find that super fun. Okay. Now let's start finessing this a little bit. And again, why Max is awesome is we don't have to worry about recompiling and do all this stuff. Cool? All right. So some other options is let's make this draw to lines at draw mode lines. So now we're seeing a little bit of, let's maybe stop it a little slower. We can see that now we're being drawn to lines. I want to have a little control over that line width, but I want to be able to do it real time. So let's go to our attributes and find line width. If I wanted to declare what the initial value was, I could put it inside the text. Right now I'll keep it at line width 1. And then that's pretty good for right now. So this is a little bit too much resolution, I think, for my uses. What we're going to do is we're going to create a new thing called a U menu for fun. New U menu. And it's a way of creating different lists of things we want to put in our object, which we want to new prepend our dimensions. Yes.
What is that line with object thing?
Line width right here. So our lines,
But what is it like impacts?
it's an attribute. So we have all these things we can do to this mesh, and I literally will sit around and play with every single one until it does something I want. And one of them is point size or line width, and those will give us and so looking at this, if I want to see what that does, it doesn't round, right? It's whole units, but it makes it like bigger lines, especially apparent when I bring it further out, thicker and thinner lines. There we go. Looking beautiful. All right, let's finish the little U menu thing and we'll move on. Let's see if this is giving me errors. Cool. So this U menu, we're going to go to information about it. What I want to do is I want to put in a list of menu items. And my menu items are going to be things like 640, 480. What's half of that? That's 320 by 240. Glorious 160 by 120. And then 80 by 60. So okay. And now I can take out the values and prepend it by dimensions. And you see the resolution of this mesh. Let's slow it down so we can actually see what we're doing. We'll go down. And we can have a little bit more gaps in between so it's more apparent where our lines begin and end. And of course, what's always important is on a handle to say calm down and reset. Back to where you began. That's over there. If I hit the I for inspector, it's down at the bottom. It has an edit for menu items, and each item is comma separated. So it's 640 by 480. 640 space 480 is one item, comma, and then it shows a bunch of different resolutions. And the performance will increase significantly as we're drawing less geometry. Right? And what we already did before on the first day I did this stuff was I created an analog digital converter, and I was able to see what the peak amplitude was at 30 frames per second, and then get that information over to thing. So now we have like a growing head or something. Right? Add in a scale object. So we can scale how much that grows in real time. And it'll be, oh, there we go. So anyway, I made a patch, and it now does the amount I want it to do. Yes. Okay. All right. So this is all I want to prove, and we can mess around with this for forever. The most important part of today is if you go back to our siphon page, we have a way of tapping into our signal to see and test what we're sending out. And these are the tools that are listed right. Let's probably go to the overview, and that's a video. Let's just look at siphons link on its own web page. Siphon. So we have Siphon Recorder, which we'll get into today as well. Let's see. Oh, here we go. Down the bottom, a simple server client. We're going to download that, and we'll be able to use that to see what information we're sending out. So in Max 8, they've greatly simplified how to send out. If I want to put this on a projection, I can do it a couple of ways. Now, of course, we're sending this reset out. We're sending that rotating out. But if I want to just corner pin this, JIT.world does do corner pinning by as a functionality of it built in, which is great because it used to be really like a lot more steps than it was before. To see this, we can just look at the help file to kind of prove it. That all you have to do is say enable corner pin, and then if I hover over the edge, let's see, let's turn it on, I can take this corner pins are there, and that's just built in for me. So very simple. What I'm calling more projection masking. If I just want a corner pin, that's been built in, and I can save the values of these corners, and then it will just load up, and I don't have to worry about anything more complicated than that. Cool. This is the help file for JIT.world. I just went over here to the arrow on the side and said help. And then I turned it on and saw that it does a bunch of stuff showing us how you do physics and whatnot. And one of the attributes of JIT.world is to enable the corner pin, giving us the visibility of these. Once I have it in place, I can then disable it, and I can't edit it anymore. Yeah.
Wonder if you would use corner pinning in Max versus just like using MadMapper or some other stuff.
If I don't want to worry about starting up MadMapper, like if I don't need a MadMapper, why would I want to use it? It's additional licensing fee, especially when that's monthly.
So if you're just using like one projection surface.
Yeah, if it's a simple thing,
Yeah.
why go more complicated?
Yeah.
When you get into the scripting for MadMapper, like MadMapper, you have to go past like a splash screen or an OK screen, and it requires like doing Apple scripts where you have to actually take a mouse and move the mouse so that it says OK. And so I think there's a new setting on MadMapper where that doesn't happen. You can bypass it. But why add more complexity, especially when certain software is to be loaded in certain orders? You're creating more scripting and more chances for your thing to fail. So, if you don't need it, then don't worry about it. Like just do the corner pin, and it's fine. Yes. You can do the same thing with a 3D object, but it's ultimately this is a final raster, so that it's going to be warped, it's going to be skewed, right? So we're taking all this stuff. Oh, to project on a 3D object? Yeah, yeah. So these are 3-dimensional objects that are being corner pinned.
I think what you're talking about is called vertex displacement. That's like a new technique where you like are taking a 3D object and you're like pushing out towards it. Yeah. So if you can talk about it, but that's
So that's why when I was talking earlier about going into open frameworks using a thing that used to be called Mapparappa that's now been put into Touch Designer, instead of doing corner pinning and mesh distorting, you could do vertex pinning, where you're dealing more with like triangles and stuff, and you're moving the triangles to be on triangles, right? There's a couple of projection mapping software that are in competition with MadMapper that do specifically that. I think one's called MVW or something. I used to have it. In fact, I think it's on this computer in a demo mode. I looked at it, and that was like its main feature was that it does do vertex mapping instead of mesh distortion. We can look at that up later, and I'll give it to you. I might have just uninstalled it. Okay, so let's go back to the siphon spout thing. So we have this world. Let me tame this a little bit. We want to send it out to MadMapper. Okay. What's great about the new workflow here with the JIT.world is that we can tell it to output a texture. Going to the attribute output texture, and then when I click on this, it'll send out an OpenGL texture here over the first outlet. I can create a new JIT.gl texture just to hold it real quick. Cool. And then Max has a thing called the package manager. Did you do this one? Package manager?
I don't know if I showed it.
So it used to be you had to find externals and place them, but now they made a really seamless way of searching for them with this package manager and installs it for you. Again, this is platform operating system specific. So we're on Mac right now, so we would do Siphon, and then right here we see that Tom Butterworth and Anton Marini, and we can install Siphon. Spout right there is Lynn and Bob Jarvis, the father-son DJ team, VJ team. I want to see them in action. But we're not on Windows. You can have them kind of side by side, but they'll error out if you do it on the wrong platform. I already have it installed, and I'm just going to say new.jit.gl.siphon server. So I'm the server. I'm sending it out to a client, and I just need to give the server a name, and I'm going to say at server name jitter, and hook those up. Siphon has its own help file, but it's a little bit dated, and it does it through an older technique of doing stuff. But you can reference the fact that you're getting a texture and sending it on a server, or you can receive it on a video plane. And you need to give it a name, like we just gave our server name jitter, so that we receive that name. It's all about naming these contexts so you can receive them on separate names, because you can send multiple contexts at one time. So I have a thing called the simple client that I just downloaded, and to prove that this is now leaving Macs and going to another application, I have to click output texture, and there I am, upside down again. We can just fix this by saying I'll do a little attribute called at flip 0, and now we're back where we are. I'm driving it here, and it's going to another application. Cool. If this were to be Mad Mapper, so be it. I'll put the demo up because I don't have a serial this month for Mad Mapper. I just need to create a mask to work with. So there we go. On the left side, I've created a little quad. And down here at the bottom of my list of things is my Siphon for Macs. Double click it in, and now I have a Mad Mapper out, right? And I'm sharing this texture amongst all my applications. Could grab this without any problems and do things with them and blend them together. We could just go kind of like infinitely, right? It's kind of a Tower of Babel. Cool. So from Mad Mapper, then we have all the different mesh warping capabilities that we have inside of After Effects that we had, where we could say mesh warp, and then we could say how many subdivisions. And this would have made a lot more sense if you guys had been able to see the mesh warp and how many of these subdivisions there are. And there's like 50 subdivisions to try to do those corners at the IFB center. Maybe not 50, but it's definitely like 25 or more. And then you can mesh distort and make things map on an object, which would be fun if you guys want. We'll make sure we can check out projectors and try this in a workshop soon. Cool? So we've done Siphon in. I want to take a break real quick. Not like a real break, but like a fun break for me, and talk a little bit about OpenEmu. Have you done this one? All right, so this is an open source project for Mac only. This is called OpenEmu, and it's actually it's a video game ROM player. So if you guys ever traded ROMs, you guys know ROMs? Come on, man. So you can have like Nintendo ROMs and Sega ROMs, and it's a way for you to play like Contra and a way to play Donkey Kong, and you go to a place to download all your ROMs and you play it through OpenEmu. Cool? So like I have OpenEmu here, and I have like Contra, and I can actually get a little USB Nintendo controller and play the game of Contra, which is a favorite of mine. All right? So it's loud over there. Anyway, so right? Can somebody turn it down over there? Right, and it's up and left and all this kind of stuff. Thank you so much. Thank you. So we're now playing Nintendo, and I have a Sega controller. I was playing with it yesterday. Or no, PlayStation controller. We played it yesterday, but we might notice on this GitHub repo, somewhere down at the bottom or somewhere on the contributors, you can see there's a little name that we might find familiar, and that name is Anton Marini. And Anton Marini contributed Siphon to OpenEmu. So let's go back to our max patch real quick and disconnect the jit.grab. So you've seen enough of me. And let's do the opposite and say new jit.gl.siphon client. Cool. Let's do a little help and see how do we, let's see, oh, it's called OpenEmu, so it's at name OpenEmu. At app name OpenEmu. Emu means emulator, you're emulating these games. Cool. And let's see if we're getting anything here. No. Let's see if I'm doing it right over here. Yes. Turn it on. New jit.p window. Alright, so I see it there. Is it not app name? App name, one word. Am I doing one word? App name. Maybe I need to send it some bangs. Let's do that. There it was. Give it some bangs. It's paused because it's in the background. And that's a setting that you can turn off and on. Alright. So this is a CPU object, this is a GPU object. If I was going to be really particular about this, I can convert this back to CPU and then convert back to GPU. We can use Visi for that. New VZ, and it's it's called texture to matrix. Get it back into our CPU, and let's see where the hole is. It would just be really slow, I think. That's fine. That's fine. That's all it is in there is just one object, which I was like, oh yeah, okay. Just do what you can, and don't stress. Just chill. All right. So let's just stop and start again. I don't know what's going on. It's working all the way down to the very bottom. We're not sending out a text anymore. That's why. Yoink. There we go. So now we're getting Contra. And one of the settings was to not stop rendering in the background, but for right now, Mario never was any better. Cool. On a Mac, it's very easy. There's a thing called Soundflower that routes, and also on a Mac you can combine. You can aggregate sound devices to send them out. I think Jack Audio is the only option you have on PC. Those are the VBA DVDs. Okay, I didn't get any luck with that whatsoever. I tried 4 years ago though. Okay, so there's a few ways of routing audio. Soundflower used to be the easiest way. It's also made by Cycling74 that makes Macs. Yeah, so here we go. Now we're playing video games and DJing and stuff in real time. Cool.
And so if you wanted to let's say you had a playlist and you wanted you had an audio playlist and you wanted the sound to correspond to this output.
Yeah.
Would it be your internal audio that you'd be using?
Yeah, you could probably route the audio from OpenEmu to this. We're just getting my microphone anyway.
Right.
But if you want to have it more of a controlled environment, yeah. Just trying to close this. There we go. That was a little bit aggressive. This is more my speed. Anyway, I just thought it was really fun. Yes. Can you turn that just a little bit more? So blended together. Yeah, so then you're going to start dealing with like the shader world of doing it instead of Xfade. Xfade is a CPU object. And remember when I first opened up jit.gen? So there's these shader, not I wouldn't say all shader, because there's the two main objects for OpenGL shader programming are jit.gl.pix, PIX, which is a way of doing two-dimensional color information, and then jit.gen can do the three-dimensional information. It's where you get into for doing particle systems and where you're doing our RUD. And when we first opened it up, it had two inputs, and it was going to a plus, I do believe. So those were at doing two OpenGL additive, right? And then it was an out. So you can mess around with doing a standard crossfade would be more like doing a multiply, and you create a system which I think you came up with for coming up. So left side is all the way one on one, and right side is all the way one on the other, and that would be parameter inside of that.
When you make a digital slide from the file name, there are a lot of figures that
So you can hold a shader file in a couple ways. The most classic way is jit.gl.slab. If you look at the help file, it'll kind of, I think it should have a list, like that U menu of all the different kind of shaders, and then there'll be a lot of options, and one of them will probably be like a SLAB. Yeah. Again, I was trying not to introduce, the world of jitter where there's a million objects, and each one has like some sort of weird archaic reason why it's called the thing it is. Like the fact that brightness, contrast, and saturation is Berkosa. You just have to know that's Berkosa, or the fact that if you want to do certain kind of color changes, you need to know that there's a peace, love, unity rave that's happening. That's called jit.plur. So some of them you're like, oh well, but jit.slab usually the shader types are GXS mainly, JXS normally, and these are just text-based files that very much like JSON markup kind of stuff with code. Yeah. Anyway, so that was another jam-packed fun day of stuff. And I'm going to stop the recording somewhere in the world of. Oh yeah, let's do that. That's right.